Welcome back. Today's lesson involves solving systems of equations using elimination. Now, with the elimination method, you want to make sure that every single variable lines up. Now, what that means is that x's are over x's, y's are over y's, your equal sign is in the same place, and your constants are lining up in the same place as well. Do they always have to be in standard form? No, but they do always have to be in the same place as each other, including where that equal sign is, because that determines which side of your equation it's on, thus its placement. Now, sometimes you get lucky and you have a system of equations like this one where you have two variables that have perfect opposites for coefficients. Now, sometimes you're almost lucky, like in number 2. I have two variables that have the same coefficient, but they're not opposites. And then you get down to situations like 3 and 4. Now, I consider these progressively a little bit more challenging in terms of the number of steps, so we're going to go through all 4 today. The key to elimination method is to literally eliminate part of your equation, primarily one of your variables, by adding straight down. I always try to add straight down. If I'm always doing addition, then I don't have to worry about suddenly forgetting one of my signs. Now, if I add this equation straight down, something absolutely magical happens. Negative 4x plus 4x becomes 0x, and 0x does not have to be written in the problem. It's almost like it vanishes. Negative 2y plus 8y. Now keep in mind that minus sign is actually a negative sign now that I've eliminated what's in front of it. So negative 2 plus 8, it acts almost like subtraction, because they're going in opposite directions, which means that I have a positive 6y. Now, why is this positive? Because I have more positive than negative when these two do their canceling act. I have to carry down my equal sign where it is, and then negative 12 plus negative 24. Now, both of these have the same sign, which means that they are actually adding on to each other, but in the same direction that they started out in. So I'm at negative 12, and I'm going 24 more negative, which means I have a total of negative 36. Now, just like in my previous video, your goal is to try to get a variable by itself, solve for that variable, so that then you can use it in one of your other equations to find that variable, thus finding the solution to the system where the two lines cross each other. In this case, we're dealing with lines. It's not always lines. To get y by itself, we have 6 times y. The opposite of multiplication is division. It's the 6 that was doing the multiplication, so it's the 6 that we are dividing. And y equals negative 6. Now, that means that my second coordinate of my point, remember this always goes x first, then y, is negative 6. Once I have the value of one of my variables, I can go back into one of my 2 original equations and put that back in. Now, I'm going to do that with the bottom equation simply because I have more positive numbers, and I like dealing with positive numbers if possible. So I'm going to take that 4x plus 8 times my number that I just found equals negative 24. Now, it's the y variable that I solved for, so it's the y variable that I'm replacing, which is why it's the y variable that my parentheses went in place of. And then the negative 6 that I just found is exactly what replaces that variable, because y equaled negative 6, so negative 6 is now in place of y. 4x will carry down. 8 times negative 6 gives you negative 48. And notice that as I'm writing this out, my negative sign now became a minus sign. That's how you deal with the signs in front of these, knowing whether you're dealing with addition or subtraction. Positive 8 times negative 6 is negative 48. When you write negative 48, it shows up as subtraction. Equals my negative 24. Now, once again, that reverse order of operations, I need to deal with any addition or subtraction before I deal with multiplication or division. The only addition or subtraction I have is minus 48, and so that's what I'm going to undo. The opposite of subtraction is addition, so I'm going to add 48 to both sides of this equal sign. Negative 48 plus 48 is 0. 4x plus 0 is just 4x. And then I have my equal sign. And then negative 24 plus 48, these signs are going in opposite directions, which means they are going to cancel into each other, thus acting like subtraction. And let's see, 48 minus 24 would give me a positive 24. Now I can undo my multiplication. So 4 times x, it's the 4 that's being multiplied, so it's the 4 I need to divide by. And now I have x equals positive 6. And this goes up here to become the first coordinate of my point. And now I have my solution to my system of equations. This is the point where the two lines would intersect each other. How do I know that these were lines without graphing them? Well, both x and y are both to the first power. Now, my second one here. This one is a tiny bit more challenging because if I were to add right away, I would double my y variables instead of eliminate them, and I wouldn't make any headway at all on my x's. Now, if I were to subtract these, then these could cancel out, but I said at the beginning that I always like to do addition so I don't mess up some of my signs. So what I'm going to do is multiply this bottom equation by a negative 1. The 1 keeps all the numbers the same, but the negative sign changes all the signs. I also like to rewrite my equation when I do this. So that top equation is staying exactly as it was, but the equation at the bottom is now, see, negative 1 times negative 3x is positive 3x. Negative 1 times positive y is minus y. Negative 1 times negative 5 is positive 5. Do you see what I mean by this allows you to ensure that you've already dealt with all of the signs that you need to? And now when we add straight down, 8x plus 3x is 11x. Y plus negative y is 0y, eliminating it, equal to negative 16 plus positive 5 leaves me with negative 11. I didn't have to worry about guessing on any of my signs. Should I leave them the same? Should I change them? I already changed them, and I could be sure of my step. Now, in order to get x by itself, again, I need to undo this multiplication, and it's 11 times x, so it's the 11 that I'm dividing by. And that leaves me with a 1x equal to negative 1. And the reason I'm not writing down the 1 is because we can assume that this is a single x. If I'm writing down the x, we have at least one of them. And if I didn't put a number in front of it, then I only have one of them. Now, my starting point, the start to my intersection point is negative 1. And now I need to use that in one of my two equations. Now, it doesn't matter which equation you use. I'm going to use this bottom one just for the heck of it. I don't really have any other reason than that. So it's going to be negative 3 times a number plus y equal to negative 5. And the number that I'm using in place of x is what x equals over here, which is negative 1. Negative 3 times negative 1 is positive 3, plus y equals negative 5. Now I need to isolate that y again. This positive 3 is the thing keeping me from having y isolated, and positive 3 is just like plus 3. How do you undo addition? With subtraction. Or think of it this way. What do you do to positive 3 to get 0? You subtract 3 from it. That leaves you with y equals negative 5 minus 3, which is negative 8, and you have the second coordinate of your intersection point. Negative 1, negative 8 is the point where these two lines will intersect each other, thus being their solution to the system. Now, once we get down to problems like 3 and 4, I'm just going to set these up to be able to do the elimination step and leave you to complete the problem. For this first problem, I don't have any convenient variables that have the same exact coefficients, so I look for the next best thing. Can I multiply just one of my equations by a number to be able to get the same coefficient but with different signs in front of the other ones? So, in other words, I'm asking myself, can negative 3 be multiplied by something to get 9? The answer to that one is yes. Similarly, can 5 be multiplied by something to get 7? Not a nice integer. So I'm going to deal with this top equation. And what times 3 gives me 9? 3. And I need different signs. Do I have different signs? No. So I need to change my signs and multiply by 3. That's how I come up with the fact that I need to multiply by a negative 3. And if I rewrite this top equation, everything multiplied by negative 3, I get 9x. Remember, negative times negative is positive. Negative times positive here gives me negative 21y. Negative times negative over here equals positive 48. And then I can rewrite my second equation right below it. And now I'm ready to add straight down. And again, I'm going to leave that to all of you to finish. See what happened here though? My x's are going to eliminate each other. I'm going to do the same sort of method with number 4. Now, can 3 become 5 easily without fractions? No. Can 2 become 5 easily without fractions? Again, not really. Now, can I multiply each equation by something to get a common number? This is where I start taking kind of a shortcut. I'm going to take these first two numbers. I'm going to multiply each equation by the opposite equation's number. So I'm going to multiply 5 into the top. I'm going to multiply 3 into the bottom. Now when I check this, I would get 15x and 15x. I don't really care what the rest of this becomes. I'll care in a minute, but for the solving purposes, I just need these numbers to become the same. Now I don't want them to be too much the same. I want them to have opposite signs still so that when I add, they eliminate instead of double. Remember our lesson from up here. If they're the same sign, they would double, they wouldn't actually eliminate. So I need one of these to change their signs. Does it really matter which one? No. So I'm just going to put it where I have the most room. Now if I multiply these, I would have a 15x plus a negative 15x. That would eliminate, so I'm good to carry through the rest of my multiplication and rewrite this. I would have 15x minus 10y equals 10. Negative 15x. Negative 3 times negative 5 gives me plus 15y. Negative 3 times positive 10 gives me negative 30. And then I would add straight down. And again, I'm going to leave this problem for you to finish.